Okay, good afternoon. Assalamualaikum warahmatullahi wabarakatuh. The honorable speaker for today's session, Professor Mitsuhiko Kataoka from Rikyo University, and the honorable head of Department of Economic, Bapak Dr. Repol Ferry Prasetya, the honorable lecturers from Department of Economics today who joined today, and our moderator for today, Ibu Indri Supriyani. So today, let's continue with our 3-in-1 program. For today, we will have Professor Mitsuhiko Kataoka, which will present about the cyclical shocks and spatial association of Indonesia district level per capita income. And today's session will be moderated by Ibu Indri Supriyani. And without further ado, the screen is yours, Bu.
Spatial, like, good afternoon all, and our special speaker, Professor Mitsuhiko Kataoka. How are you, Professor?
Fine, thank you.
Okay. Okay. Okay, the Honorable, the Head of Department of Economics, Faculty of Economics, University of Brawijaya, and our speaker, Professor Mitsuhiko Kataoka. And ladies and gentlemen, I'm Indri Supriyani, and it gives me a great pleasure to be the moderator in our session today at a classic cyclical shocks and spatial association of Indonesian district level per capita income. And as we know that Indonesia is one of the biggest country in terms of its population, but despite the great potential and natural resources that Indonesians have, Indonesia still face various problems in economics, especially like income disparity, income inequality, and the gini ratio of Indonesia is also still higher. So today we are very proud that Professor Mitsuhiko Kataoka can be the speaker, so we can gain a more deeper understanding about the Indonesian income per capita from the expert. And ladies and gentlemen, first of all, I would like to explain to you and introduce you our great speakers. Professor Mitsuhiko Kataoka, he is a professor in a College of Business, Department of Global Business, and he is also professor at Graduate School of Business Doctoral Program and Business, and he is also a professor in Graduate School of Business Master Programs in International Business. Professor Kataoka is a specialist which have a research interest area in regional inequality, efficiency analysis, economic growth, and regional economics. He also have super productive in publication and also research, which the very super latest, the publication of Professor Mitsuhiko is, the title is Cyclical Shocks and Spatial Association of Indonesian district level per capita income. Moreover, Professor Mitsuhiko also have various research and papers, especially in Indonesian cases, like disparities in regional productivity, capital accumulation, and efficiency across Indonesia. And more previous research in 2020, Professor Mitsuhiko also published an article which the title is Total Factor Productivity Change in Indonesia's Provincial Economics, which published in 2020. Moreover, I can mention all of the publication from Professor Kataoka because the professor is super productive, and one of the book chapter or book that published by Professor Kataoka is the title is the Government and Country Achieving Common Goals, which published by Indonesia Indonesian Regional Science Association book series in 2014. So without further ado, I believe that the participants here would like to gain more deeper and a comprehensive understanding about the income per capita and income disparity in Indonesia. So please, Professor Katauka, I think the time is yours.
Thank you very much. And yes, and thank you very much for Professor Indri Spriani, and for your, to introduce myself. Okay, so that, yes, I'm very honored to, present my recent published papers and, in Asian economic journals, and just, published that, last month or early this month. Okay, so that, yes, and this studies is initially started to that, a conference is in Milan. Very fortunate. Yes, I attended, yes, Indonesian Regional Science Associations in Milan several years ago. Then at that time I present, papers of that, these topics. Then I'm very glad to, present of today is my, final output. Okay, so that, yes, can I share my screens?
Yes, please, Professor.
Okay, so, okay, let me start my presentation today. Okay. Okay, so everybody, do you see my slide?
Yes, Professor.
Okay,
it's already on the screen.
Okay, so let me start my presentation today. Okay, so that today I'm going to discuss or presenting about cyclical or cyclical shock of the special associations of Indonesia's district level per capita income. Okay, so that yes, this is a paper from that Asian economic journals. Okay, so I hope that everybody shares my papers in advance. Okay, so this is a lecture of my CVs. So already Indri Spriani is already introduced my CVs. So I would like to skip it. Okay. Oh, anyway, I have some lecture experience in the 2019 is in the Bravigia University. This is a picture of that, yes, professors and also that, a student. Okay, so some of the student is studied at my school. Okay, so anyway. Okay, so today is, I mainly, share that, about topics of these papers. Okay. So I hope that everybody already shared that my papers with you. Okay. Okay, so first of all, I would like to explain about summaries of the papers. Oh, anyway, Ibu, Indrinya, how many hours do I have? How many minutes? 60 minutes is all right?
Yeah, it's okay, Professor.
Okay, so 60 minutes and presentation and other is Q&A session, right?
Okay, so we will have discussion and ask question and answer following the discussion.
Okay, good. Okay. All right, so let me continue. Okay, so that, object, these summaries as papers is, mainly, talk about explanatory special data analysis. Okay, so I would like to explain more about, what is exploratory special data analysis is. Okay, objective of this paper is that, this studies explore the followings. So Indonesia's, as you know about that, there is many high income, district and low income district. Okay, so district is, Kabupaten and Kota in Indonesia. Okay, so that, and so these, high income and low income district is located nearby each other or far from each other. Okay, so we would like to detect, numerically. Okay, so and also we would like to identify where, high or low income clusters or high and low income outliers located in Indonesia. Okay, so that location has been changed a lot last, 15 years or not. And do regional cyclical shocks influences spatial autocorrelations? Spatial autocorrelation is that, special, income clusters relations, income outlier relations. Okay, so here is in my presentations, special autocorrelations and the special associations and the special dependencies that, I use that interchangeably. Okay? And then, our fourth objective is which factors influences that, trend of the special autocorrelations. Okay? So I would like to focus on, rich mining resource, district relatively, fluctuate special autocorrelations. So I would like to just, show that, one examples relation between, natural resource district and the special autocorrelations. And the method is very simple. And, we use that, I use that, global and local Moran I and gear is C. So I would like to explain the method in more detail. Okay, so data is, I use that, regional or macro data, district level panel data of the per capita GRDPs, and its coordinate. Okay, so coordinate is the location of the longitude and latitude. And then this is a panel data, and in Indonesia is currently 514 districts. So here is that, I would like to just make that, consistent number of the 554 districts for 15 years, from 2004 to 2018. Okay? And then, I use that, cyclical shock to find that, cyclical shocks. Okay? I would like to use that, filtering technique. Okay, this is a time series, filtering techniques. It's very popular techniques. Podrick and Prescott are filtering techniques. Okay, so then I would like to derive the two values. Then non-filtered income per capita. It means that, with regional shocks. Then also filtered income per capita without regional shocks. Okay, difference between these values is cyclical shock. Okay? So this is very simple, method, but I combine the two simple methods, then I, provide new, findings. Then there's, summary findings. There's 6 summary findings. So weak but monotonically increase in special dependence, and also several high income clusters that are resistant to the regional cyclical shocks persistently exist. Okay, so they exist especially in that, Jakarta district in Jakarta, and also district in resource-rich provinces, such as East Kalimantan and Riau and Papua. Okay. The nation decrease. Okay, so first I would like to focus on inter-district income gap. Okay. The nation, Indonesia's experience decrease in inter-district income gaps, but nearly half of the all district widen income gap with their neighbors. So we found some, conflicts. Okay. In the nation level is income inequality is going to decrease. But if we see with neighbors, okay, if we focus on relation between one district and their neighbors, okay, nearly half of the all district increase income gap with neighbors. Okay. And also regional shocks widens income gap with neighbors rather than reduce it. Okay. The regional shocks influence special associations more largely in resource-rich district. Okay? Because resource-rich district economies is relies heavily on volatile commodity market prices. Okay? So international commodity market price. And also finally, high and low income clusters closely located in Papua and West Papua. Okay? So thus, regional specific development plans are essential to these areas. Okay? So this is major, findings. So, and also a summary of that, findings. So here is from now on, I would like to explain more detail. Okay. So before that is, I just, would like the contribution of the, these studies to existing studies. So what is new? Okay. So new is use the district level special data per capita GRPs. Previous study mostly, focus on the province level and identify the location of the special income cluster and outliers. So this is, special data analysis is not, popular, not very popular in Indonesia, and also examines the influence of regional shocks on special clusters and outliers. So this is never studied before. And covers alternatives, relatively long study period. I covered 2004 to 2018. It's covered 15 years. So that that kind of relatively long period is studies never done before. Okay, so apply. Then simply my studies is just simply applied filtered per capita GRDPs data to spatial data analysis. So both studies are probably most of the undergraduate student is already studied. It's not so difficult in a method. But if you combine two simple methods, you can provide that new findings. Okay, so presentation time from now on, I would like to each of the detail, rest of the minutes. And first of all, research questions and literature survey. This is the introduction. Then I would like to explain about the method, exploratory special data analysis. So we, sometimes call ESDA or ESDA. Okay. All right. So it's some of that study already student already knows. Okay. So if you know that, please review your analysis. But if you don't know this method, please learn from today's my seminars or lectures. Okay, so here is I would like to introduce us two indicators: global and local Moranzai and global and local Gyarizushi. Okay, so this is that both are one of the popular method of ESDA. Okay. Then I would like to explain the data and measure findings. Finally, I would like to draw the conclusions. Okay, so initially, I would like to introduce the research questions and literature review. Okay, so here is a map of Indonesia's. Okay, so this is, I just pick up that, my papers and figure 1. Okay? So regional income gaps in Indonesia. Okay, so this, map shows per capita GDPs or gross regional domestic product in year of the 2018, final observation years. Okay? So I just, categorized 4 groups from, higher income to lower income groups. Okay? More, darker red is higher incomes. Lighter, red colors is lower income. Okay, so as you can see, apparently, high income areas is located to, this North and East Kalimantan and Riau and also some, Papua, West Papua, and Papua, areas. Okay, so those are, you can see all are rich natural resource, district. And also, of course, we can find, around that, Javas and neighboring district, and also East Javas and neighboring district, and also Malang areas, okay, also, one of the rich district areas. Okay. So here is Indonesia's world largest island countries. Okay. And the population size is fourth, largest in the world. And as you can see, these maps, you can find that, coexistence, rich and poor income regions, district in a nations. And here is rich nations are developed and resource-rich district, and also scatters across the nations. So since, given these, income gaps, interregional income gaps is, key policy issues in Indonesia since, nation's independence. So starting from this, kind of the background. So here is, so interregional income gaps. Measure of the interregional gaps is very important for in Indonesia's, research topics. And then, I would like to more details about, income inequalities using geographic data. Okay? So now we focus on spatial data analysis. Okay? So spatial data analysis is to, detect of the pattern, the modeling relations using the spatial data. Okay? So here is we are going to use the spatial data. Okay, so probably, some of you already know what is spatial data, but others not know. So I'd like to explain. Okay, so spatial data means, geographic informations. Okay, so what geographic means? Okay, so I just show that in examples. Here is one sentences, okay, or one phrase. The population in Tokyo's, okay, so latitude and longitude 35.41 and 139.41 in 2019 is 13.9 millions. It's very huge, population size. Okay? So this, one phrase, this statement contains information about attribute. Attribute is a characteristics. Okay, so for example, is the population size. The population size 13.9 millions, and also here is times data, year data. Okay, 2019, and also Tokyo's has its own geographic information. Okay, so if we focus on coordinate or longitude and latitude. Okay, so here is Tokyo's locations is latitude is 35.41 and north, and the longitude is 139.41 east. So these, coordinate data, okay, sometimes we call or spatial or geographical data, linked populations and time series data. So this data is we call spatial data. Okay? Using these spatial data, we are going to analyze. So here is, location data. Okay? Give you more variables informations or variables analysis. Okay? So next is, based on the spatial data, we would like to know, okay, and relation between, two locations. Okay? For example, here is, I would like to introduce Tokyo. Okay, in Tokyo is neighboring there's many neighboring, prefectures or cities. Okay? So we would like to, suppose we would like to know relations, Tokyo and neighboring cities or neighboring, prefectures. Okay? In that cases, we use that, concept of the special autocorrelations. Okay? Or, in other words, we use that special clusters or special distribution dispersions. Okay? Special autocorrelations present characteristics of the special data. Okay? So special autocorrelation is the number of the similarity numeric similarities between the object. Okay? So we are, in the cities, there's many surrounding, cities. Okay? We would like to know that relation between one city to other cities. Okay? So here is that, we can categorize two, characteristics of relations, okay? Special clusters and special dispersions, or we can say special outliers. Okay? So special clusters means, in other words, we can say positive special autocorrelation or special associations or special dependence. Objective with similars or different attribute located nearby or away from each other. Okay? So here is, suppose, okay, so this, dot, okay, is indicate university locating town, okay, such as Malang and Semarang and Depok, and there's many, university locating town. Okay? So here is, those university located town is located nearby each others or far from each others. It depends on that, variables or example. Okay? So if that, university locating town nearby each others, locate nearby each others, okay? So object with similars, in this case is, university locations, okay? Similars attribute located nearby each others, we can say special clusters, okay? Or objective with different attribute, okay? So it means university locating town, non-university locating town, far from each others, we can say special clusters, okay? In this case. In that cases, that is in a positive special association or autocorrelations. Okay? On the other hand, special dispersion are outliers, negative special associations, objective with different attribute located nearby each others, or objective with similar attribute away from each others. That we can say special dispersions. So here's, okay? So this dot is university locating town. This university locating town far from each others. So here is compared to, this one. Okay? So negative, special association is far from each others. So this is, we can say negative special associations. Okay? So here is, as I mentioned, special associations or special autocorrelation is also called special association and special dependence. Okay? So here is, we can categorize, or we can classify clustered or dispersed or randomly located. Okay? So this is a special autocorrelation. So my purpose is detect these relations in entire nations, or identifies each district. Okay, so why we need special data analysis? Okay. So suppose, in Indonesia, there's huge, income gaps. Okay. So suppose, to measure the income gaps, normally we use this, for conventional regional income equality measurement. Okay. Coefficient of the variations, Gini coefficient, tile index or tile T index, tile L index. Okay. So formula is just like this. Right? So, but you don't have to remember. Right? So what I would like to say, okay, so here is YI is per capita income in each regions, and Y bar is arithmetic mean of YI. Okay? Since Indonesia's, consists of the 514 districts. Okay, so if we would like to calculate mean income values, we just, sum all income divided by 514 number of the district. Okay, so here is, we denoted Y over bar. Okay, so here is, coefficient variations is just, we can see each, incomes to, cross region means. Okay? Cross regional means. Here is, we calculate deviations between regional in each region's income, district income, and cross district means and square values. And also, here is tile decompositions. Okay? Also, here is cross-section, regional means and each regions. And also, here is cross district means. And only Gini coefficient is, compares region-wide incomes, other regions' income. Okay? So, but, above measures the relative distance from cross-regional means or other region income. Okay? So these all above that ignored geographical locations. Okay? So here is, we would like to know, we know that, here is, we know that, overall income inequalities, okay, in, nationwide. But we would like to know more about which region is more, show the more unequal or large income gaps. Okay? Or which region is, grouping together. Which region has high income clusters. Which region is low income clusters. So those, conventional regional income measures does not answer, our research interest. Okay. Then here is, I just calculate regional income gaps based on, 4 conventional regional income inequalities. Okay. So apparently, we can see all 4, regional income gaps measurement index is declined, but we don't know from this data where that high or low income district tend to locate nearby or far from each other, or where the special income clusters or outliers is located. Okay? So these questions are probably policymakers, okay, or policy planners would like to know. Okay? But this measurement index does not answer. Okay? So that's why we are going to use special association or special autocorrelations or ESDA. Okay? Then based on that, now we would like to focus on locations of special clusters or special outliers. Okay, so here is, the same, figures, same graph, maps of, as I show that, this is figure 1. So, and then I circle it, okay, high income, areas. Okay? So here is, we found, several high income areas, Riau and also Riau Island provinces. There's many high income, district, and North and East Kalimantans, and Papua and West Papua. And also here is Jakarta's, and here is, West, West Java's and Jakarta, and also East Java's. Okay, so here is, we have the high income clusters. Okay, the map shows several high, or probably we can see the low income, clusters in Maluku, in West and East Nusa Tenggara. Okay, so the maps shows the several high or low income provinces located closer together. Okay, so here is, we categorized high and low income clusters. So spatial data analysis detect presence of the locations, clusters, and outliers numerically. Okay. So here is, we would like to just identify or detect by specific indicators. Okay, so this is okay, so the final introduction point. So here is, then, I just check previous literatures, right? So focusing on regional income gaps in Indonesia. Okay. So since Esmara 1975, so, her studies triggered, okay, regional income inequalities in Indonesia. Then after that, many studies examined regional gaps. Okay, so more than, nearly 50 years ago, and using household data, sustenance data, and GRDP per capita. Okay, so this is, I just, list up 10 most cited papers. So Akita Luckman, 1995, is used as population weighted coefficient of the variations that, use that, sectoral and aggregate level of, province level GDPs, okay, province level data. Then Akita and Setos is tile decompositions and aggregate GRDP per capita and province level. Okay. So as we can see the studies, okay, so district level study is not so many. So this one, and that one. Okay. So mostly the district level study is only these 3 studies in the past. Okay. Then I would like to focus on Akita Alice Jabana. Okay. Alice Jabana is at Amida Alice Jabana, professor of that UNPAD. Okay. Now she is at SCAP head. Okay. And she use the tile decompositions, aggregate GRDPs per capita, and also Akita is tile decompositions. Okay. Then Guannan is use at the CARS convergence analysis. Okay. So this is convergence, means that low income catch up with the high income. Okay. It's kind of that dynamic transitions analysis. Okay. So here is only 3 studies, only use that district level data and also GRDPs, but use that tile decompositions and CARS convergence. No studies is district level, use the district level GRDPs and explanatory spatial data analysis. Okay, so these research gaps. Most examined overall interprovincial income inequalities. Few studies identifies trend of the location of the income clusters at district level. So to fill fields, research gaps. So I would like to, so I have just started my research in the several years ago. Okay. Then objective of these studies. This study is explore the following using district level GRDP per capita. Okay, so I would like to mainly, focusing on four things: magnitude of the special autocorrelations, location of the special, income clusters and the outliers, how regional cyclical shock influence the special autocorrelations, and which factors influence special autocorrelations. Okay, so this is the introduction part. Next, I move to the method. So I'd like to mainly, explain about exploratory special data analysis, ESDA. Okay. So this, explanation lecture note is, I shared with my, student, who are taking that, my urban and regional economics class. Okay. So I just, would like to share that, most basic part of this analysis. I hope you understand. Okay, so method is explanatory special data analysis. So ESDA is description of statistical analysis of geographic information. Okay? So this is a descriptive statistics analysis. Okay? There's no cause and effect. Okay? So here is just we would like to use that three method. Okay? So three indicators: global Moran eyes and Geary's C's. Okay? So this examine the magnitude of special autocorrelation in entire nations. Okay? So it means, if we see that, entire nations, that, that suppose, in this case, Indonesian district per capita GDPs have, show that special autocorrelation, positive special autocorrelation or negative special autocorrelations. It means, district tend to locate it nearby each others or far from each others. And then this is global, indicators. And next is we will focus on the local. So local means, it means we would like to identify each district show that, negative or positive special autocorrelation or negative special autocorrelations. Okay? So global means entire nations. Local means each object or each district. Okay? Identify the locations of the special income clusters and outliers. Okay? So here is one, is we would like to show that, overall trend. The second one, okay, so first is overall trend. Second is focusing on each district trend or each district that, special clustering or special dispersions. Then finally is Moran scatter plot. So classified each district. Okay, so we identified each district has, special clustering or special outliers. Then we are going to each district into 4 categories: by relative incomes and by neighbors weighted mean income. Okay. So here is, we have the two, variables. Then suppose this is 1, this is 2. We have the 1, variables and 2 second variables. Then using the first and the second variables, we would like to, categorize 4 quadrant. Then this is that, Moran scatter plot. I would like to, explain more detail. Yes. Then first of all, I would like to explain global special autocorrelations, global special associations. So global Moran's I and global Geary's C. Okay. So here is global Moran I takes, between -1 to +1. So here is if global monoline I takes -1, it means strong negative special associations. If I takes +1, strong positive special autocorrelations. Okay? So it means strong negative special SA means special outliers or special dispersions. Okay? Strong positive SA means special clusters. The similar object is located nearby together. Okay. And -1 means different, different. Okay, so a similar object is far from each other. Okay. So here is we can see that same special association, negative and positives using that global Geary's C. So global Geary's C's takes 0 to between 0 and 2. Okay. So here is if C is equal to 0, strong negative special association. If C is equal to 2, special positive special strong positive special association. Okay, so here is, so we, so here is, so here is, takes, non-negative value. Okay, so this is formulas. So here is global Geary's C takes that, both are squared values. So it means do not take non-negative values. So anyway, to calculate global Moran's I, global Geary's C's, global Geary's C's. Okay, so we need each income of district level incomes and Y bar. Y bar is, sorry about that. Y bar is mean of the per capita GRDP. So I just reverse it here to be consistent with other slide. Okay. Okay. And this WIJTs is weight indexing district I relative to J. Okay. So I'd like to explain about this, what is WIJT. So this is we call special weight matrix. I made just a mistake. Sorry about that. This is sorry about that. It's I made a mistake. So if she is zeros, is strong positives, special autocorrelations. If she is negative, okay, she equal to 2, strong negatives relations. Sorry about that.
It's okay, Professor Katoka. Never
Thank you
mind.
very much.
Yeah.
Okay, so let me continue then.
Okay, so please, Professor.
Okay. Okay, then I would like to relation. Okay, so here is I would like to briefly explain about this global monoline I takes between -1 to 1. So here is, just compares correlation coefficient. So correlation coefficient, you are very familiar with that, this statistics, if you studied that, statistics, elementary statistics before. Okay. So this, coefficient correlation takes at -1 to +1. If takes -1 is negative correlation, if takes +1 is positive correlation. Okay. This is the same as, special, Moran's I is the same as, correlation coefficient. Okay. So just, switching correlation coefficient to, Moran's I is just, this is, switching R to I. Okay. So here is, we use this, formulas. Upper side is covariance, numerical denominator is variable, okay, standard deviation of each variable. So here is just, we put that, special weight matrix and change into, we use that, not two different variables. We use that, same variables, but different locations, okay? I and J. So if we switch this, part from correlation coefficient, we can calculate, okay, global Moran I. So global Moran I is extension to correlation coefficient. Okay? So that's why I takes between -1 to +1. Okay? Then here is we can, interpret. So here is global Moran I takes -1 to +1. And if that, greater than 0 is special clusters, is less than 0 is, special dispersion, or negatives, special autocorrelations. Okay. So if that, global gear is seized, if takes, greater than 1, it means special dispersions or special outliers. If that less than 1, special clustering. Okay. Then also that, if we focus, okay, if disaggregate. So here is, so we have, okay, no, this is, global values, global indicators. Then we are going to focus on local indicators. Okay. Here is local indicators. Okay. So local indicators is, each district, each object, each object has special associations or clustering or dispersions. So here is, we have that, one summations, symbols. Okay. So it means we just, calculate, this is J. This is J. So just we calculate, sum of that, J's, values. Okay. So here is global Moran I. You can see two double summations. Okay. So it means aggregated. And here is we have only one summations. It means we can identify each, district, special autocorrelations. Okay. If this is the same, if that, local Moran I is less than 0, it's special distributions, and is greater than 0 is special clusters. Okay. So local global C is also same. But now is it takes that, greater than, 1. Okay. And also local galaxies is greater than 2. And also that, once we calculate, okay, descriptive statistic of spatial data analysis, we can identify, statistical significant test, okay, for Moran's I. So here is, we can calculate, we assume that, normal distributions, and then we calculate, Z values. Okay. So mean values of local Moran I is minus 1 divided by n minus 1. Okay? So this is nearly zeros. For example, is, in Indonesia is n is 514. Okay? So this calculation is close to nearly zeros. Okay? Then if that t statistics or z statistics scores is greater than 1.96 or minus 1.96, we can reject no special autocorrelations null hypothesis. So then we can identify special autocorrelations, positive values and negative values, that is statistically significant or not statistically significant. And then local, Moran's scatter plot. This is third method. Moran's I did indicate correlation between variable y and the special lag y formed by average of all values of y for the neighboring areas. So here is Moran I. So here is, we can see, we can weight it Wij. So it means, relative distance from I to object, district I to J. So here is, we can calculate this one and that one. So here is, so this J probably neighbors, including neighboring district. Sorry about that, but Yj is, possibly be neighbors. Okay? So here is, these are, we would like to just, shows x-axis is yi. Okay, so this, x-axis yi, y-axis is double ij, y, j. Okay, so this is the weighted value of neighbors' income, or in this case, we use a crime rate. So here is, and also we would like to transform standardized form. Standardized form is this one. Local Moran I, or incomes. Standardized form is, sorry about that. Standardized value is incomes divided by standard deviations. Standard deviation of the Yj or yi value. Anyway, so here is that, we just transformed both, x-axis and y-axis is standardized values. Okay, then we are going to categorize. So here is, one regions and one region's incomes and, weighted region's income. Then we are going to compare. This is all, both greater than zeros, or, y-axis is, greater than zeros, but x-axis value is less than zeros. Then we can categorize these four, groups. Okay, so Moran scatter plots, using Moran scatter plot, what can we say? Okay. So it means each quadrant corresponds one of the 4 different types of the special associations. Okay? So here is, this is both, x-axis, y-axis is both greater than zeros. It means, from average values, corresponding district shows high incomes, and also neighbors also shows high income. And this one, quadrant 2, is corresponding, x-axis shows the negative values. So it means corresponding incomes, standardized value is lower, relatively lower. But, a neighboring is higher. It means here is, we can categorize this is negative special associations. Okay? So this is, corresponding is high, neighbors is also high. It means positive special autocorrelations. Okay? Both are high values. Okay, so quadrant 3, this is that, corresponding income is low, and also neighbor is low income. It means low and low, positive. Also, this is positive special associations. So quadrant 4 is high. Okay, so this is, corresponding income is high, but weight, neighbors, weight value is low. So this is, high and low, clusters. Okay? So here is low and lows. Okay? So this Q1 and Q3 is similar, district is nearby together. High incomes and high neighboring incomes is nearby together. So here is low income district and lower neighboring district is nearby each other. Okay? So this is that positive special autocorrelations. And Q2 and Q4 is low high, high low is negative special associations, okay? Or outliers. Then we can categorize these 4 groups. Okay, then special weight matrix. Okay. So here is a special weight matrix is nearest of the all object I and j. Okay. So here is we just show the relation between one region to neighboring regions. Okay, so I would like to skip this part since time constraint.
Okay, Professor Katalka, it's a gentle reminder that we have 10 minutes left before we jump to the Q&A sessions.
Okay, so how many minutes do I have?
10 minutes left, Professor.
10 minutes, yeah? Okay, good. Okay, so I would like to move to...
Thank you, Professor. Please continue your presentation.
Yeah, thank you for your reminding me.
Thank you, most welcome.
Okay, so here is just we use a continuity-based special weight matrix. Okay, suppose A, B, C, D, E, F. We have this district. Right? So here is we have that suppose A shares that borders B and D. Right? Okay, so here it if shares borders is one district shares border is equal to 1. If not, is 0. Okay, so here is A is just shares border B and D. It means 2 district shares borders. In case of the B, the shares border is A. B is shares border A, E, C. Okay, so it means 3 district shares borders. Okay, then we can calculate row sums, right? So this is a standardized special weight matrix values. Okay? So just we would like to know that closeness of that district. We just one way to evaluate is shares borders or not. Okay? But also we have that another approach, distance basis, or within the distance, we can see that many calculation approach. Then here is in the GDPs, I would like to clarify two, categorize the two values, trend component and cyclical component. So here is that business cycles. We can see cyclical components. Okay, so here is we can see that these business cycles, GDPs, is fluctuate year by year. Then we can see that if we calculate long trend is just like this upward slope. Difference between actual values and long trends, this is cyclical values. Okay? So actual GDP is a short run, low data trend, and long run is trend, potential GDPs or full employment GDPs. Okay? So here is I would like to just calculate actual GDPs and long run trend GDPs. Okay? Gap between this value is cyclical. This means shocks. So this is what I have done in this, my papers. So here is, I use that, 541 data, but unfortunately, okay, so then I, in the 2004, district is 440, but 2013 is 541. There's no, retroactive adjustment provided by BPS. So I just, calculate using that, population weighted values. Then I, create panel data. Okay, then empirical result. So here is first of all, I calculate global Moran eyes and gear is C. So global Moran eyes is I could see that statistically significant. Okay, but weak positive special autocorrelation. It means so global Moran eye is takes 0.0124 and 0.120. So it means we can see the gradual increasing trend, but value is very close to zeros. It's positives and statistically significant, increasing, but very weak. Okay? And also we see, gear is C's below that one, and but very close to one, and also decreasing. So it means increasing trend. So here is the rich. It means entire nations, the rich districts located nearby each others, or poor districts located nearby each others in entirely. But that trend is very weak. Then here is we see two different values. Okay, so here is without with squares is filtered values. Without square is non-filtered values. Okay, difference between filtered and non-filtered. This is a cyclical component, regional shocks. Okay, so gap between non-filtered and filtered is regional cyclical shocks, and then influenced special autocorrelations. Okay. Then non-filtered values in the Moran's eye statistics exceed the filtered one, only 4 years. Okay. So here is only this years and this years. Others are all less than, or not exceed, did not exceed. So it means cyclical shocks more frequently widens income gaps with their neighbors district rather than narrowing. Okay. So here is also we can observe same patterns is gear is C. Okay. So this is one finding, and also I just categorized 4 clusters, 4 categories using Moran scatter plot. Right? So how does move to categories from these 2 years. Okay? Non-filtered and filtered. Okay? So here is, we can see 106 is the same as, during this 2 period. 90s is during this period is the same, and 142 is the same and low values. Here is HL is the same as that, during the 2 period. So here is if we calculate each of that, each categories during the 2 period, over 2/3 of the district within each quadrant remain unchanged. There is no, change from HA to LL. So this is very, few district has been changed. Okay? So here is Indonesia experience increasing positive spatial autocorrelations without major interclusters transformations. So total number of the HH and LL are larger than those H and HL district. Okay? So LL clusters groups present largest district group over the world. So LL. This is low income groups nearby together. Low income district nearby together. Okay? So this is at poor income district clusters. So this is that majority of in filtered or non-filtered. Sorry about that. Non-filtered values. Okay. Also, statistically significant local Moranzai. So okay. So here is dark red is high income clusters and or dark blue low income clusters. And light red is high income outliers and light blue is low income clusters. So here is a different location between left hand side and right hand side is, this is non-filters and filters. So it means within the regional, with regional shocks, without regional shocks. Difference between two, maps is existing presence of the regional shocks. So here is, this one is we can see, regional. Okay, so here is special clusters, but corresponding, areas in filtered value, there's no, darker red. Okay? So here is, effect of from the regional shocks. It's more observed in the resource-rich provinces. So here is I just, here is just I plotted. Okay? So relation between mining sector's contribution to GRDPs. Okay? This is that periodical average, and standard deviation of the special autocorrelations for 15 years. Then we can see the trend. Okay? So overall trend is upward. Okay? So it means more mining shares, more variations. Okay? So rich resource provinces that income variation is much more. Okay? Then I can just plot it for quadrant. So for quantile 25th and 50th, 70th. Okay. So here is slope of the 25th is smaller than 50th and then 75th. It means more dependent, the economy is more dependent on natural resources, is have the more special association variations. Okay, so and the location, okay, so high and low, high income clusters and low income clusters, especially Papua, that is nearby together. So it means one, district is very high income and high income groups. And then here is, another, next is located is very low income group is located. So it means there's no interregional trade or interregional, resource mobilities. So that government should, focus on, developed transportation or not. Okay. And also high-low clusters closely located. Okay, this is what I said. And also, this is location persistent special association or immune to shocks. Okay. And this is a district is, 11 district is persistently is, keep that special autocorrelation for entire years with, special regional shocks. And then here is very interesting, Sambawa Barat, West Nusa Tenggara. This is that, keep high income and, high low categories. It means enclaved, phenomena because of Sambawa Barat is large scale gold and copper mining site. It means only this, district has high income, but all others neighbors is keep low income. Okay. Then here is, I would like to skip one. Okay, so I would like to also skip the conclusion. This is I already mentioned. Okay, I would like to stop that my lectures. So if you need if you need more, yes, probably I can answer, from your questions. Rest of the slide.
Okay, Professor Kataoka, thank you very much for Professor Kataoka for giving such an informative and comprehensive presentation regarding income per capita, and particularly on Indonesian context, which I believe that all the students here and lecturers, and including myself, gain a deeper understanding about the current economic condition of Indonesia. And I would like to say this is an excellent advanced research which have a significant contribution practically and theoretically for Indonesia. Okay, and from your explanation, Prof. Kataoka, I have written some highlights. And first, by utilizing the annual observation of district level per capita GRDP for 514 districts at constant 2010 prices for 2004 to 2018, and Prof. Kataoka research discovered that there is an income distribution imbalance, especially in Eastern Indonesia, which cover West and East Nusa Tenggara, Papua, and West Papua. Actually, Prof. Kataoka, I came from Sumbawa, which you have mentioned before. There is yeah, right. There is Aman Mineral, or maybe you known as Newmont. There is a mining corporation, so that's why there is a high income disparities and inequality between Sumbawa and others region. But I'm strongly relieved that your research have concluded that the national average in Indonesia is moving forward and narrowing the inter-district income disparities. So I think that's positive, and I hope that Indonesia can continue have a greater and lower Gini ratio. So, Professor, I think we have to go and jump to the Q&A session, and I believe our participants have absorbed so much knowledge from you. And as you mentioned, that income per capita is significantly important to measure the economic condition for each country. And Indonesia, despite have great and positive GDP trend for maybe 3 years later, but GDP itself cannot be, cannot be really measures the economic condition in Indonesia, because we still have so much economic problems actually. So that's why here in decisions, we are go deeper to understand about income per capita. So we have maybe three session questions, Professor. So dear students, after we know about the comprehensive outlook of income per capita, hence I would like to invite the participants to raise hand and open the camera and also the microphone to directly deliver the questions and discuss with Professor Katoka, as Professor Katoka is the expert on income per capita. Please, dear students. Okay, I think there is one student that raised her hand or his hand from Alit Jacob Majok. Are you there? And also Alton Zaki Azhar also raised his hand. Please, Mr. Alit.
Yes.
Okay. Please deliver your question to Professor Katoka,
Yeah.
Mr. Alit.
Yeah. Okay. Thank you very much. Yeah, it has been a wonderful presentation from Professor Katoka. So my question, I will be straightforward. My question, yeah, as exhausted about the income inequalities, but my question is, let's talk about that there exists income inequalities between districts in Indonesia. Some districts have more income compared to other districts, and that could be due to allocation of resources by nature, or could be by policies. So my question is, so what is the way forward, or what suggestions should we do as Indonesians to capitalize or to bring gaps together, those districts which are not developed or where income is low, such that they reach the same level with other districts which are developed. So what is the way forward? This is my question, and thank you for the presentation once again.
Okay, we all agree that the presentation is so wonderful. So thank you, Mr. Alit, for your question. And please, Professor Katoka, you can elaborate the address question from the students.
Okay, so that thank you very much for your questions. Your question is at the policy implications. What is policy implications from that my findings? Am I correct?
Yes.
Okay, good. So, okay, let me share my slide again. Okay, so that very good questions is I would like to, some students would like to hear. Okay, so. Okay, one of my, striking policy implication is I identifies that locations of high income district, high income district and low income district. So normally high income district is so nearby together, and high income district is there's no low income district is near together. But here is only West Papua and Papua as exceptions. Okay? So here is located is high income clusters and low income clusters is near together. it means we can find that, huge economic or income imbalance as a group size. So here's West Papua and New Papua, okay? Blue and red is coexist each other's nearby together. It means there's no, economic interregional transactions between two, districts. So it means we can find huge economic gaps as a group level. So in that cases, government should, intervene. So very fortunately, the government plan to regional highway, Papua inter-regional highway during these areas. Okay? So it means if that government create transportation network, okay? It means there's that improved inter-regional trade or inter-regional mobilities between low-income regions and high-income regions. So that is, kind of the reduce that, income gaps. So my, policy implications, main policy implication is just like this. So Indonesia is now many, transportation network is big project is, underway. From Bandung to Jakarta was Surabaya to Jakarta, okay, highway networks and also transportation network. That one of the main objective is that reduce the income gaps. So this is my policy implications. Okay, thank you very much for your question.
Okay. Okay, thank you, Professor Katoka, for a deeper explanation. And if I add that your policy recommendation is, as we know, Indonesia have rapidly improved the infrastructure, so maybe it can help the agencies to build and have a greater connection. Okay, thank you, Mr. Alit. And I saw that there's two more students that raise his hand. Is it Alton here?
Yes, I'm here.
Yeah. Do you have any question, Alton? I saw that you raise your hand.
Yes.
Please, Alton, directly
Yes, I have
asking to
a question
Miss
for-
Professor Katok.
Yeah.
Yeah, sure.
So, Professor Katoka, I want to ask you a question about high income and low income of each district. So, I was wondering how the government will want to raise the low income district to a high income district, and if what is it? And is every district have to be high income district so that all of the people in Indonesian are equally matched and they have no issues about the economics? Yeah. That is my questions.
Okay, thank you very much.
Okay.
Yes, Pa Elton, and yes, that is very good question. Yes, everybody, or probably almost all, policymakers, concerns about, improve that income in lower income, district. Okay? So here is, probably there's many approaches. So one approach is just I mentioned about, build what creates a transportation network between low income regions and high income regions. Okay? So it means, okay, suppose, if, there's, a very good, transportation network. Okay, so it means between that low income regions and high income regions, suppose, low income region has a main, a leading industry is agriculture. Okay, so high income regions is, a main industry, leading sector is probably, high-tech manufacturing. So here is low-income regions is, agricultural product can easily sell to high-income regions household. If that, there's very good, transportation network. transportation cost is become lower. So it means interregional trade between two, high and low income region is, well established. Okay, so this is one way to reduce that income or increase that, income of low income district. So another way is, just improve that, okay, so income is determined by capital and also, yes, capital and labor force and technologies. Okay? So here is, capitals is, divided into physical capital. Physical capital is just like, plants and also factories and tools and machine and so on. And also human capital, okay, is a knowledge, educations, and skills. Okay? So here is low income regions is, there's a lack of physical capital and human capital. But to increase that, to increase that lower income to lower incomes, probably is, if that lower incomes, district has more physical capital and more human capital, probably that low income region is increase that income. So then, the income gap is going to decrease. But, this is very good way. But if, government do that, probably that, resource is initially must located in the high income regions. But instead to the high income region to, reallocate to the lower income regions. So it means high income regions economic growth is relatively going to decrease. So low income regions is going to increase, but high income regions potential, economic growth is going down. So government have to control that kind of trade-off. Okay, seeking for inequalities, reducing the inequality gaps, or increasing that economic growth. So government always, considers which must be, emphasized. So this is that, there's several policy options, but there's also constraint and trade-off. So government, can do several approach, but the government considers also trade-off and constraint. So this is my answers.
Okay, thank you, Professor Katoka. That's a very detailed answer to the questions. And if I can add, Professor Katoka, I mean, the Indonesian government also have various policy to improve the economic activities and economic condition of Indonesia. And also it's in line with the goals from Sustainable Development Goals, which no poverty and also the income equality for all the community. Okay, thank you, Mr. Elton, once again for your questions. I think we have several minutes left. So if the students and all the participants here still have the questions, please raise your hand, because it's a great opportunity and of course scarce opportunity to directly ask to the expert. So please. Okay, Professor Katoka, our student here is range from first year, freshman, and also the students on the, actually on the end of their college. So maybe there is a difference understanding about the level of understanding from the students. Can you please maybe elaborate more why we have to measure the economic condition by using income per capita instead of GDP? I know this is basic questions, but I would like to ensure that all the student here know the basic understanding about the difference between the two of them to measure the economic condition and activity of a country.
Okay, so just I missed that. So student would like to know the difference between GDP per capita and what?
GDP and income per capita, because
okay.
yeah, okay.
Good,
Yeah,
very
thank
good
you.
question. Okay, so that okay, so let me share my slide.
Please,
I'd like to-
Professor.
Yes. Okay. Per capita GDP. Okay, so this is that, per capita, I measured per capita GDPs. Per capita GRDP is the same, gross regional domestic product. Okay? So this is kind of the income. Per capita income is the same. Okay? Okay, so income is, we can measure as many, approach. Okay, so probably incomes. Okay, so probably it's very, very small space. I need more space. Okay, so incomes, you can measure GDP per capita, or also labor incomes, and also wage. Or if we cannot, get the incomes, we can get that in expenditures. Expenditures equal to consumptions. So we can use that in many variables. So here is, in that, we have the data constraint. So I would like to know, 2004 to 2018, district level. Only satisfy that this data is GDP per capita. So labor incomes and wage, we can, get that, Helnas, Indonesian labor force, surveys, and also expenditures we can get from Susenas. And Indonesians household survey data. So these are not, provided each year, in several years, and also categories and sample size are different. So only GDP per capita is, get that, for these relatively long years. And GDP per capita is GDP divided by populations. Indonesian government issues every year. So this is that's why I use that GDP per capita.
Okay. Okay, thank you, Professor Katoka, for your explanation. I hope the students have again the deeper understanding now regarding the difference between the GDP and income per capita. Dear students, is there still any question for Professor Katoka? Please raise your hand. Okay, Professor, I guess all the students is overwhelmed by your explanation. They are so absorbedly with your presentation today, and I hope they have get a better and deeper understanding about income per capita.
Okay, so if time allows, and can I explain about my programs? Just 3 minutes. Is that okay?
Yeah, Yeah, that's fine, Professor. Please go ahead.
Okay, good. Okay, let me share my slide again.
Yes, please, Professor.
Okay, so do you see my slide?
It's already on the screen,
Okay,
Professor.
good. Okay, so here is probably, today's topic is bit technical for undergraduate student. Okay, so probably master student probably easily to understand, but for undergraduate student it's not, easy. So, yes.
Specifically for the first year, Professor.
Okay, first of year of undergraduate.
Yeah.
Okay, so
That's
it's
right.
okay, so it's a bit difficult, né? Okay, so I didn't know that I expected, masters and PhD students will join. Ne?
Yeah.
Okay. Okay, so here is, just I published, just, if Professor Indiris and Sprianis is introduced my, books. Okay, so this is what, income inequalities, about income inequalities. Okay? So this is that kind of that wrote for that, upper undergraduate, seniors or sophomores undergraduate or masters, first year master's student. And there's also that, many applications in Indonesia. Okay? So if you'd like to more about income inequalities in Indonesia, if you'd like to write a papers as a, undergraduate thesis or master thesis, I suggest to, read this, books. Okay.
Okay.
And yes, you can ask to that, your library. And also, if you would like to study more, and please visit our university's website.
We will love to.
Yeah. And we have that, double degree programs. Okay? And also, you are, student from that Brawijaya is studied our universities is that, before the COVID. We have the double degree programs, and we very welcome to, your studies in Japan. Okay. Thank you very much for your, listening. I very appreciated that your question.
Most welcome, Professor Katoka. And apparently, we still maybe have several questions that maybe the students kindly shy to ask directly to Professor.
Yes, I know that.
Okay, and okay. However, due to the limited time, we need to end our discussion session. And ladies and gentlemen, we have finally come to the end of our webinar for cyclical shock, and from Professor Mitsuhiko Kataoka. I'm sorry, Prof, for misspelling your name, Professor Kataoka. Okay. Before I close these sessions, I would like to invite Professor Kataoka to give us some short closing remarks. Please, Professor.
Okay, so that thank you very much for listening my lecture. Okay, so today's lecture is, yes, as I just know that you are first year student of undergraduate. Okay, so that I should explain more, select more, yes, basic topic. But probably after 2 or 3 years, you will understand what I explained today. Yes, and then after that, you can start writing your papers, or you can conduct your own research. Probably, think about, what you listen to what you listen today, and probably, one of the possible your topics in your, graduation thesis. Okay. I hope everybody enjoys studying the economics and also econometrics and statistics. So this is my concluding remark.
Okay, thank you, Professor Katoka. As you mentioned that we have to enjoy the research and the study process, especially the statistics and econometrics. I believe that our students will love them, the subject so much, Professor. Okay, thank you, Professor, for the concise closing remarks and innovative And please allow me to also giving some points and from your sessions. The first is Indonesia is also experienced a positive growth regarding the income inequality, as your research finding that Indonesia have moving forward. So I hope it's a first sign of positive growth. And the second one, Indonesia have also various homework, I think, especially the government to reduce and brings the gap of income equality, particularly for in the level of district. So Professor, thank you very much for your presentation. And finally, ladies and gentlemen, I would like to send my sincerely appreciation for Professor Katauka for his informative and interesting presentation, and also to all participants, all students for their active participation during the webinar. And please give applause for the speakers, and for you all, you can giving a reaction from the Zoom. There is a reaction of a clap hand and thumbs up for the professor. Okay. Okay, thank you, Professor, once again. Maybe we can having a screenshot for the photo sessions. So please, the participants, turn on your camera so we can spot the attractiveness for the students. Okay, we have almost 100 participants. Okay, we can count on 3. Okay. Please be ready. 1, 2, and 3. Okay, thank you for the professor. Thank you for the students. See you all in the next agenda, and I would like to see you in offline, Professor.
Yeah, see you in Manande.
see you. Okay. We will love if we can talk directly, Professor.
I'll visit Manande.
So we will meet again, Professor, officially, physically.
Yes.
Okay, thank you, Professor.
Terima kasih banyak deh. Sampai jumpa.
Sampai jumpa, Professor. Selamat sore.
Selamat sore.
Good afternoon.